In this video, we will walk through a deployment of FortiSandbox in an existing AWS VPC. There are several configuration options available that may use multiple VPCs, multiple availability zones, clustering, and so forth. For our example, we will keep it simple. As organizations adapt to new computing and networking paradigms in the cloud, threat actors and their advanced malware are taking advantage of cloud migrations and the potential vulnerabilities and inconsistencies that are exposed by these migrations. Preventing these advanced threats in cloud requires a multi-layered approach. FortiSandbox offers the ultimate combination of proactive mitigation, visibility, and rich reporting. In the continuum of data types that cross the network, there is known good and known bad, and these are typically easy to spot with traditional systems. But what about unknown or suspect content, where polymorphic or zero-day threats reside? This is exactly what FortiSandbox solves for. The FortiSandbox executes content in a contained emulation environment to establish the nature of the content and data. Once a determination is made, threat data is distributed across the security fabric, raising the fabric security posture in real time. The results are dramatic in terms of time to discovery and impact. When added to Fortigate and or FortiWeb deployments, detection and response is taken from days down to minutes or even seconds. Let's discuss a simple deployment. In our scenario, we will install the FortiSandbox alongside of Fortigate in a single VPC. The FortiSandbox doesn't necessarily need to exist in the same VPC or even AWS. Our simple demonstration could be a security DMZ as an example. The table to the right lists the subnets and security groups used in our sample. When deploying FortiSandbox, we must have a minimum of 2 network interfaces. At least one port is required to communicate through the internet, and here port 2, which in this case is EC2 instances Ethernet 1, will be the source of our communication to hosted Windows and Mac VMs used to detonate our suspect code. You'll notice that Ethernet 1 is also used for scanning submissions from the FortiGate. Now keep in mind that this could also be FortiWeb, FortiMail, or other fabric-connected solutions submitting files. Ethernet 0, with an elastic IP assigned, can also accept scanning requests from outside of AWS. Now regarding internet connectivity, direct attachment to the IGW is required to prevent the FortiGate or other appliances from potentially having unnecessary malware traverse them or realizing an impact to their IP reputation. With this basic overview, let's review the deployment of the AWS objects required to support this. We'll start by configuring AWS. The steps here are add additional subnets to the FortiSandbox, launching the FortiSandbox AMI, creating and attaching the scanning interface to the FortiGate, configuring our security groups, updating route tables with proper next hops and IGW connections, and lastly, we'll attach our elastic IPs to the FortiSandbox. Let's move into our AWS demonstration.
We'll start with an existing VPC. Here we call it Secure DMZ. And then we'll navigate to subnets and we'll create a new subnet. We have a couple of subnets that exist, but we'll create our scanning subnet right now. This will connect our FortiGate with our FortiSandbox. We'll attach it to our appropriate VPC and availability zone. Give it the proper CIDR range for that subnet as laid out in our table previously shown, and we'll create that. And lastly, we'll repeat for the last subnet, which is our FortiSandbox internet connected subnet. And this will handle all of our internet-based connectivity, including malware, FortiGuard, and external VMs. With this, we should have all 4 of our subnets created, and we can see those listed here. With our subnets completed, let's move over to EC2. We see that we have an existing FortiGate and our existing Bastion host. So let's move into Marketplace, and we're going to launch our FortiSandbox. Now there are 2 options for FortiSandbox. One is for on-demand, and one is for BYOL. In this instance, we're going to launch the on-demand version. Here we see some of the pricing and instance details, including additional resources such as data sheets. Selecting Next will allow us to choose our instance type, where the default is M4X large. We'll stay with that. Choose Next. Here we can build our instance details. Now we want to make sure we put it in the right VPC and attach it to the correct subnet. So what we want to do is select our FortiSandbox public subnet. We have to have 2 interfaces here, so we're going to add a second interface. This is going to be for our scanning, which will be connected to the FortiGate. Select Next. You can add additional storage if needed, but typically it's not necessary. So let's move on to adding our tags. We're just going to add the name tag of FortiSandbox and click Next. Our default security group is here. These are the minimum ports required, and this is our internet-facing connection, so we'll leave the default. And finally, here's a summary of the AMI that we're creating. We're going to add our key, select Launch Instance, and here we can launch the instance. With the FortiSandbox launching, as we can see here, the next step is to attach our scanning interface to the Fortigate. Within EC2, we're going to select Network Interfaces. This brings up a list of our interfaces, and we're going to create a new network interface, and we're going to name this Fortigate Scanning because it will be attached to the scanning subnet connecting us to our FortiSandbox. So we need to select the appropriate subnet here, which is our DMZ scanning subnet. Select the appropriate security group. Here we already have a DMZ scanning security group created. And this security group aligns with the proper ports required for that network interface and that subnet, which are ports 443 for SSL. Everything is encrypted as SSL traffic in the scanning interface to the FortiSandbox. And TCP 514 will allow connecting devices to establish a connection to the FortiSandbox. The next step is attaching the interface we just created to the Fortigate. So simply select Attach at the top of the screen, select the proper instance, which is our running Fortigate, and it will attach. Step is to update the route tables, and we do this from our VPC console and then navigating to route tables. Select Create Route Table. We're going to create our scanning route table, and we're going to attach it to the proper VPC. And let's go ahead and select Create. And with our scanning route table created, we need to make sure that it has the appropriate subnets associated with it. And this is going to be our subnet that we created for scanning. So we'll select that. For this route table, we only require a route for the local CIDR. And this is because traffic will only be destined from or to the Fortigate or the FortiSandbox. So we don't need an IGW or some other route as a next hop. The second route table we need to update is the public subnet route table. And this subnet is attached to our IGW. And here we'll make sure that we associate both the FortiGate's public subnet and the FortiSandbox's public subnet to this route table. And this is because they share a common IGW. Our last step in configuring AWS is attaching the elastic IP to the FortiSandbox. So here what we have to do, because we have multiple interfaces, is select Network Interface. We're going to find the one labeled FortiSandbox Public, and that should just bring up a single IP that we've associated with, and now we can associate that IP address. And with that, we've completed our AWS configuration. Let's move on to configuring the FortiSandbox directly.
Configure the FortiSandbox. The first step is to edit the system DNS with your preferred DNS hosts. Edit default routes. Configure VM clones, which is optional. In this case, we're going to enable MAC clones. We're going to edit our scan profiles. We're also going to authorize devices, which is required to enable devices to submit files for scanning. And lastly, we're going to test our network and file scanning to make sure it works.
For our FortiSandbox configuration, we'll grab our public IP. Navigating to the admin console, our default user is admin, and the instance ID is our password. It is recommended to change the password on first login. Here we can see that we have all of our services enabled because this is an on-demand instance. A BYOL instance would not necessarily have these enabled as it would require a perpetual license. Next, let's go to Network and Interfaces. Here we can see both ports that we've attached to our instance and their respective subnets, so this is correct. Next, system DNS. In our example, we're going to change this primary to 8844 and all 8 as a secondary, but this can be anything that you would like. Next, our system routing. We have 2 default routes, one tied to each port. What we want to do is for port 2, change that to our internal VPC CIDR, as all internal communication should occur over that network. We'll keep our all zeros, all hosts route as our default route for our port 1 for all external communication. Next, Let's go to VM images. Here we see we have a number of clones licensed for 8. We want to enable 2 Mac OS X clones, so we have to add 2 here and then subtract 2 from our Windows Cloud clones. And this is where our malicious or suspected malicious software will be executed. Next step is to add a device. So to do this, we're going to jump over to our FortiGate and navigate to our security fabric and settings.
We'll enter the IP address that's associated with port 2 of the FortiSandbox. This is our internal interface and the one over which we'll connect our FortiGate. And as expected, it's unreachable because we haven't yet authorized the FortiGate on the FortiSandbox. By navigating to Scan Input Devices on the FortiSandbox, we can go in and authorize that particular FortiGate that now shows up. You see the status is up, and if we rerun that test, we now see that it's connected. That concludes our demonstration of a FortiSandbox deployment in a simple VPC. Thank you for watching.